Coding agents produce 24% more merged pull requests. But nobody wants 24% more code if it also produces 30% more review work. The number is real, and the study behind it is serious. 3 Microsoft researchers tracked the company's own rollout of Claude Code and Copilot CLI across tens of thousands of engineers. Published this July. The method matters. They did not just count pull requests before and after. They built a counterfactual, an estimate of what each engineer would have merged without the tools, and measured the gap, 24%, with a 95% confidence interval from 14.5 to almost 34. And the effect scales with use. Engineers who touched an agent 1 day a week merged about 15% more. 5 or more days a week, 50% more. Whatever this is, it is not a placebo. One more finding hides in the appendix. Adoption did not spread through memos. If your skip-level peers used a tool, your odds of trying it tripled. Your manager using it nearly doubled them. Coding agents spread through people watching people. So that is the headline. Here is the asterisk. And it comes from the authors themselves, printed inside the same paper. Read that again. Merged pull requests reward small, frequent changes and can completely miss the quality costs. So here is everything this study, by its own admission, did not measure. 6 numbers. We are going to chase each one. Start with review. PRs tracked telemetry from 22,000 developers across 4,000 teams, comparing each company's lowest and highest AI adoption periods. Median time in review did not creep up. It went up more than 400%. And when review cannot keep up, teams do not review faster. They review less. Pull requests merged with no review at all rose 31%. Is Alford. The gate did not get wider, it got left open. Next, defects. CodeRabbit reviewed 470 real open-source pull requests, 320 written with AI, 150 by humans alone. The AI-assisted ones carried nearly 70% more issues each, and the worst category, performance problems, appeared 8 times as often. Those issues do not stay in the diff. Back in the PRs telemetry, production incidents per pull request went up 240%, and bugs per developer rose 54%. The extra code ships. Then it pages someone. Third, rework. Code churn, the share of merged lines deleted again soon after, rose over 800% under heavy adoption. And a Stanford team watching 100,000 developers found the gains concentrate in fresh, simple projects. On complex work in old code bases, the effect can go negative. The Stanford team's phrase for the failure mode, spinning your wheels. There is even a gap between what developers feel and what the clock says. In a 2025 randomized trial by Meter, 16 experienced open-source developers worked 246 real tasks. With AI allowed, they were 19% slower. Afterward, they estimated AI had made them 20% faster. Early tools, small sample, honestly dated, but the feeling and the clock disagreed by 40 points. And the slowest poison is maintainability. Git Clear analyzed 623 million code changes, duplicated blocks up 81%, refactoring down 70%. And the share of work touching code older than a year has collapsed by 3/4. Nobody tends the garden anymore, they just plant. Last, the bill. The Microsoft paper itself flags that token spend at scale runs into millions of dollars a year. Industry-wide, per token prices fell almost 98%, and enterprise AI bills tripled anyway, because agents consume tokens by the millions per task. Heavy agent-driven use now runs hundreds to thousands of dollars per engineer per month. Numbers from other people's telemetry are one thing, so we built the smallest, honest version of this experiment we could. 5 tiny, well-specified tasks in a Sandbox repository. A coding agent solves each one and opens a pull request. What the agent never sees, a hidden QA suite, and a minimal reference patch for comparison. Here is what a throughput dashboard saw. 10 tasks across 2 runs, 10 pull requests opened, 10 declared done by the agent. A merged PR counter would call this a perfect score. Then the hidden QA ran. 5 of the 10 pull requests carried a defect the agent's own tests never caught. 1 did not even parse. The agent shipped a syntax error and called it done. My favorite failure is the rounding task. The minimal fix is 3 lines with a decimal type. The agent hand-rolled its own floating point arithmetic instead. Its version passes the visible test and quietly rounds $4.99 up to $5. And the rework metric produced the strangest result. We told the agent exactly which case failed and asked it to fix it. It confidently returned the identical file, byte for byte, 0 lines changed. Stanford calls it spinning your wheels. We watched it happen. Small model, 5 tasks, a sketch, and not a census, but the shape matches the telemetry. Now the reversal, because this film is not a debunking. The 24% is real. The dose response is real. The study is careful, and it claims exactly what it measures, nothing more. Throughput is not the lie. The dashboard that stops there is. Because the same evidence tells you exactly where agents pay. Daily, practiced use, small, well-specified tasks, fresh code in popular languages, and every merge still walking through a real review. That profile gets the 50% lift with the catch under control. And where it bites, complex work in old code bases, merges that skip review, no hidden testnet, and nobody watching the token meter. Every failure we measured, and every failure in the telemetry, lives in that quadrant. There is an old law of computing about this. Speed up one stage of a pipeline, and the bottleneck just moves downstream. Agents made writing code cheap, so the queue now forms at the expensive stage that is left, human attention. So if your team adopts coding agents, and it probably should, put 5 numbers on the dashboard next to the pull request count. Review time per pull request, defect escape rate, churn inside 3 weeks, how often old code gets tended, and dollars per merge change. Then the verdict in 3 parts. The throughput gain, real, and it compounds with practice. The value, conditional on review, task fit, and QA you actually run. The merged PR metric alone, the most dangerous number in engineering right now. Microsoft proved coding agents moved the number their telemetry could see. The catch was never the 24%. The catch is everything your dashboard does not show. If you want the studies, every source is in the description, including our experiment code so you can run the missing side on your own team. Build, ship, scale.